So it is the first day of PASS, but getting towards the end of the day. Hopefully you guys have been enjoying the day. Lots of good content, lots of stuff on the DVDs that you guys are gonna have to go through, because obviously you're missing some other sessions during this slot, and there's a whole bunch of other sessions that I'm gonna be referencing that you should be seeing throughout the rest of the show. So make sure you get those DVDs. I think those are really valuable. My session, and of course hindsight's always 2020. When you write a session, as many of you know, it's hard to figure out exactly how to title it, to make it sexy, and to make people want to attend. And of course, yesterday I was telling my group, my workshop, my pre-con, that I was talking about partitioning, and they were all like, "You are? You're talking about partitioning?" And I was like, how does nobody know that I was talking about partitioning? And then I went back and looked at my title and went, I wonder why nobody knows. And so I really kind of should have named it this. But of course, hindsight is always 2020. This session is all about partitioning. And I want to tell you that even in the keynote, they made light of the fact that partitioning is really challenging. It's very hard. A lot of people don't get it right, and they have subsequent problems from having partitioned incorrectly. So this session is not demo heavy, okay? To me, the most important thing I can tell you is technology should come last. In other words, I don't want you to get wrapped up in how to create partition tables or how to create partition views or what the syntax is. I mean, I will definitely tell you a lot of the pros and cons and the restrictions and the rules and the requirements, but the most important thing I'm going to try to do today in 75 minutes is convey how to architect efficiently in hybrid workloads. And what I mean by that is a lot of you have systems where you have more and more data being kept in that system, right? You're keeping 2018, 2017, 2016, and you've actually got all the way back to 2008, 2007, and you have to keep that because somebody someday might actually query it, and you kind of know nobody's querying the data back from 2007, 2008, 2009, right? But you either have regulatory requirements, business requirements, and yeah, you want to keep that data around. But the question is, how do you deal with all of that data, especially if it's in one table, right? How do you deal with that? Because as the data ages and matures and so forth, and your varying access patterns are there, right? Your statistics are changing in some of the data set, or I should say the data is changing in some of the data sets, so your statistics need to change. Your indexes might have fragmentation, which I know some people think isn't a big deal because of solid state. But that's not the only reason to deal with fragmentation, okay? It's not just the random IOs, it's the cost of the split, it's the logging, it's the memory. I mean, there's tons of issues. You still need to do maintenance, and as your tables get larger, I even had somebody yesterday tell me, we don't do maintenance because we can't, right? It takes too long. Why does it take too long? Because all of the data is in one table. And ultimately, this session is basically going to teach you that you need to move away from having all of your data in one table, even for one sales data set. But how you do that, and notice I didn't say just partition tables, I actually said separate tables, okay? And that's what I'm going to talk about today. It's like how to deal with those data sets and solve virtually all of the problems that go along with these tables that are getting larger and larger and larger over time. And I'm going to define what I mean by larger and larger and larger. So anyway, partitioning for performance and scale probably would have been a better name. Of course, hindsight is 2020. So hopefully people will at least watch it on the DVD, because then they'll go, oh, partitioning. So you guys know the drill. I'm just going to blast through these really quickly. Obviously, you should take advantage of everything PASS has to do and share with you. It's amazing. There's so many resources, okay? And I know getting online, doing the evaluation seems like administratium and it's annoying, but we really, really do value your feedback, okay? It's important to us to find out what you like, what works, what doesn't work. So really, if you can take time to do that, and if you do that by Friday, there's actually prizes that you can win as well, okay? Just to try to motivate you. This is my background. I've been working with SQL Server, I can't even believe it now, since 1990, 28 years, but I started when I was 2. So, which I wish were true. In fact, Paul jokes, he wishes that were true, really. But, because then I'd only be like 30, right? I'm only like 32 though. All right, anyway, I digress. So I've been working with SQL Server for a long time, okay? The main thing that I tend to do from a consulting perspective is actually architecture. But architecture is not necessarily just partitioning, it's also dealing with the base table structures. A lot of that is indexes. And then of course I always get the secondary questions, why aren't my procedures using the indexes? So kind of my area that I tend to focus on the most is the tables, the indexes, right? And then caching and optimization in terms of statistics, plans, and procedures. And that, to me, that's my bubble, that's my world, right? And I focus on all of those things, and I really enjoy it. But if you come up and start asking me questions about availability groups, I'll just be like, yeah, I know enough to be dangerous, but John's our AG guy, for example. So we all have our different areas of expertise. We all love SQL Server, but we have very different perspectives on everything. So we have a great team. Hopefully you guys follow us on Twitter, blogs, and all that good stuff. So I'll just move on. And I put a lot of my fun stuff too. As I told you guys before we started, what I'm usually doing when I'm not doing SQL is watching animals in some way. So, all right. So the session materials, I never upload my sessions until I present. Sorry, I know some of you may have gone looking for the session. I literally changed like 3 things about 4 minutes before I started. So I never upload because I'm always tweaking and thinking about exactly how I want to say something. You can also get a code for Pluralsight. If you don't have access to Pluralsight, send email to Paul. And by the way, I will upload these slides like today or tomorrow at the latest. So feel free to take pictures of the slides. I see a couple of people doing that. I'm totally fine with that. But you will get the slides. And my email is on there. Maybe you'll take a picture of this one. Because of course, if they're not there, if you all start emailing me, obviously I will make sure that they get up there, okay? But you can email me if you can't find the slides. But I promise all this stuff will be up here, and I'll make sure that all of my links are active in the presentation as well, so you can follow all the resources. Because I'm not going to cover everything about partitioning in 75 minutes, but I will cover the concepts of how to do it correctly, and then I've got about 25 links in the session to different resources for various aspects of partitioning, okay? So, as far as the agenda, I'll first define what I mean by hybrid workloads and give you some insight into kind of why VLT is a very hard thing to actually define, so I'll talk about that. And then I'll talk really about functionally partitioning data. I will take a second to talk about hash-based partitioning and list-based partitioning, only just to cover all the bases, but I'm really going to be focused on what I do the most, which is date and time-related partitioning. Then I'll spend probably the bulk of the session on the restrictions, the requirements, and all of the frustrating aspects of partitioning that if you don't know and you don't prototype, you will probably get bitten with very late in the game, and that might be too late for some of you. So there's a lot of stuff that you'll want to kind of put in the back of your mind. Am I working with that feature? Am I working with that feature? Do I want this? Because if you don't think about those things until you're already implementing or even, you know, trying to partition a table in production, because you can do that. I mean, you can do online partitioning of a table in production, right? Which, I mean, I wouldn't really recommend that unless you've well scripted things and you're ready and you know exactly what your architecture is and you've got everybody on board. I have actually done conversions in production to the architecture I'm about to show you. So, and amazingly, with very little downtime, okay? In fact, really no downtime of the database, but kind of a window of about 20 seconds where if people who had just inserted the rows within the last 20 seconds had gone and immediately looked for their row, they might not have seen it, but then if they looked again, it was there. You know what I mean? Like as we were flipping over to different structures. But my point is, there is a way to do this in production, in live systems, and convert them from sometimes incredibly problematic large tables to much easier to control, much easier to maintain, and interestingly, much better performing tables. Everybody thinks, and this is correct to think this, that partitioning is really a manageability feature. It really was intended for that. And partition tables are largely for manageability, okay? If you partition with kind of quotes around it, using that term more generically as opposed to for partition tables or partition views, like if we're not talking about specific implementation, We're just talking about this concept of breaking down a large data set into smaller chunks, not how, right? If you do that correctly, you can often get much, much better performance. And I know that's ultimately why a lot of you are here, right? You want the performance aspects of it. You're having to keep more and more data around in that OLTP environment while management is wanting to do more and more queries. So now you have, decision support. Maybe you even have a secondary server where you're doing most of your decision support, but that might be somewhat stale. Maybe you're only updating it once a month, once a week, and now people are kind of breathing down your neck saying, it's the 20th, and we only have data through October. It's not the 20th yet, but you know what I mean, right? And it's the 20th, and I want to know how we're doing with our widget sales now or whatever. And my point is we have to do more and more of these kind of real-time queries in production. And when all of that data is in one table, if that table's not structured correctly, if it's not indexed correctly, it becomes almost an impossibility to do that. And like I said, I even had somebody yesterday telling me that they don't even do maintenance because their tables are too large. And kind of my response to that is, it's almost like too late to fix the problem because now it's going to be very difficult to fix it in production, but it's still something that we can fix. So that's what I'm going to talk about here. And I say technology last because I don't want you to get wrapped up in the syntax. There are some sessions on partitioning, and there's a ton of resources I'm going to point you to as well to really get into the syntax, because partition tables definitely take a little bit of time to get used to all the different requirements, the partition function, the partition scheme, switch in, switch out, split, merge. But if you don't architect it right, it doesn't matter how much you know about the syntax. And I see so many cases where the architecture is wrong that that's what I'm going to do, okay? I'm going to talk about that. So a hybrid workload is exactly that, right? It has OLTP and decision support occurring at the same time, right? It's maybe the only system you have. It's just you've had data now for a couple of years, and you're keeping it, and your tables are starting to get larger and larger and larger. So you don't even think of it as a hybrid workload, it's just your server. You've got a lot of queries going on, you've got a lot of OLTP going on, you're starting to have problems with maybe maintenance, maybe it's taking too long, you were running certain things every night, now you're having to stagger them where you're doing like one table on Monday and one table on Tuesday and a couple tables on Wednesday, and that's now even starting to become a problem because those tables are so large that the maintenance is now taking almost your entire maintenance window, and you're starting to worry, how am I going to be able to do this in a few more months, right? Your backups, I am amazed at how few people actually do anything other than full and log backups. Well, even just full. If you don't do log backups, that's a big mistake. I would absolutely make sure that you are doing log backups, especially in an OLTP or a hybrid environment. But the beauty of architecting your tables a little differently, the way I'm going to describe, is that you might have access to partial database availability, online piecemeal restore, right? The ability even to put certain data on, let's say, LUNs that are SATA drives versus using solid state, and RAID 10, maybe triple mirroring, right, for the really critical data, because you don't want to spend that much money for that table when not all of it is really critical. And that's the large reason that I see people run into trouble, is that their tables are getting large because they have to keep that data around, but they really haven't thought about the criticality of all of the data, right? And is it really all critical? Do I really need all of that online all the time? Maybe I have a requirement to make it available and for it to be available, but in terms of the usage patterns, is it really getting used all the time? So we're going to talk a lot about that. Now, if you have a data warehouse and you are like regularly migrating over to that data warehouse, let's say daily, weekly, monthly, you are going to be optimizing for the data warehouse and then luckily not have to optimize for your data warehousing queries in OLTP, sure. So you don't need to have things like column store or necessarily have partitioning in the production environment. However, a lot of you might find that the strategies I'm going to recommend for the hybrid environment can actually also improve the data warehousing environment. I almost never and this is going to sound strange. I wrote the white paper on partition tables when they first came out. I was a huge fan of the feature. I was so excited in 2005 when they came out, right? It was just so powerful to me that we finally had this manageability capability with our tables. Like, we create an index, and the default behavior is SQL Server aligns that index to all the partitions for us. Very cool stuff. But here I am 13 years later, and in production, I really never architect partition tables by themselves. I either architect partitioned views by themselves or partition views with partition tables, but not partition tables by themselves. And I can give you one reason, just to throw that out there, because some of you will know this already, especially from my workshop yesterday, is even if you have a partition table, statistics are still table level. And as your tables get larger and as your data gets skewed, right, you really want to have better statistics. And there are ways to create filtered statistics, right? And that can be incredibly powerful, but there's limitations to filtering that there aren't with architecturally partitioning. Okay? And I mean, I wish I did have 3 days to stand up here and tell you everything. I'm gonna try. But there's just so many powerful things you can do with the right architecture. It's just in a lot of cases people don't know about this architecture. So this is the most important thing that I would say. I consider partitioning more of a concept, and the most important thing is breaking a table down into smaller structures, depending on how you do that, can really give you huge benefits, not just in availability, not just in scalability, in performance, and it's just such a powerful feature, so I want to talk about it. Okay, so think about one large table. I was debating on whether or not I would draw everything, and I might go over to my Surface here and draw some stuff, especially depending on questions. But if you have one large table and you start to think about that large table, and like I said, you have a lot of data over time. Like, you didn't have very much data, let's say in 2009, 2010, 2011, 2012. But then as we're getting closer and closer to current, you have more and more and more data. And that right now is in one table. You have 200 steps in your histogram. That's it, right? Which, the more skewed your data is, the harder it is for those statistics to accurately describe that data really well. Okay, so that's one issue. But I'm going to go through a bunch here. That older data, I would argue the requests are limited at best. Right? You know, 2009's data might go down and become inaccessible, and it might take weeks before anybody goes, aren't we supposed to be able to access 2009 data? You know what I mean? Like, nobody will even notice necessarily for weeks. And the data over there is completely static, right? It's not changing. And if you're updating statistics or you're rebuilding indexes, right? Depending on how you rebuild the indexes, I'll talk about a partition level rebuild in a second, but you could be touching all of that data that is static. And what about things like fill factor? Even if you're partitioned, fill factor can't be set at the partition level. And for your 2018 data, you want fill factors, but for your 2009 data, you want 100%. Why would you have any fill factor at all? Like, why are we even doing any management or maintenance on the 2009 data? Well, because it's in one table, right? Data is not hardly business critical, right? I mean, 2009, like I said, it could go down and people might not even notice. Your SLAs, right? Your service level agreements. What have you agreed to? And I know sometimes I put SLAs up there and people are like, what do you mean, what did I agree to? Hopefully you've worked with management, you've made agreements on what your downtime and your service levels are supposed to be, how much time it's going to take maybe for you to recover data, because that should also in turn allow you to get better hardware, right? Better redundancy, so that certain disasters maybe won't even require downtime, right? So there's so many things in terms of hardware and design and the log and backups, not my primary discussion, but if you're doing this correctly, you know, the 2009 data, if it is in, even if it's partitioned, although there are some limitations, but even if it's partitioned, if that data becomes damaged, the rest of the database can still be online and accessible. Whether it's partition views or partition tables, it actually doesn't matter. But there are some limitations if you ever want to use read-only file groups, because then it becomes difficult to rebuild indexes across the table when there are partitions on read-only file groups. So you're actually better off having them on separate tables and then having the tables on separate file groups and marking them read-only. So there's lots of tricks and benefits to kind of separating. Now, on the other side of things, the newer data, the more business critical data, requests are nonstop. Everybody will notice if that data goes down, right? You're gonna have people banging on your doors basically saying you're losing $1 million a minute or an hour or whatever because you're down. I mean, hopefully you're not down for an hour, but depending on the disaster, depending on how your environment is configured, you might have downtime. And it's actually more downtime when the tables are bigger, because even recovering these bigger tables becomes a lot more challenging. Whereas if you had broken it down into separate tables, you'll actually find that file and file group restores can actually be done with something called partial database restores. And you can end up restoring, let's say, just 2018 and 2017, and bringing the database online. And then having people insert data, make sales, right? And then slowly, over time, restoring 2016, 2015, 2014, right? So partial database availability, online piecemeal restore, all go very much so hand in hand with partitioning, but they do require the enterprise edition, just to make that point, even though partition tables now don't, okay? Data is incredibly volatile here, so you need to update statistics more frequently, you need to rebuild indexes more frequently, and the data is absolutely business critical, and we obviously don't want to be down. So these are kind of the two extremes, and if this is all in one table, we can't possibly optimize for all of these extremes all the time. So how do we do it, right? It becomes harder and harder to do this as the table gets larger. The varying access requirements, I could even argue, warrant different indexing strategies. I usually don't want as many indexes on my 2018 data, right? I want to optimize for OLTP, but I might want to have more indexes on the older data, right? I might want to use column store, and even though we can do read-write column store, and it is much better with OLTP, I still would argue that if OLTP and the speed of the OLTP is really critical, I probably wouldn't necessarily want column store on my November 2018 or my October 2018. And I'm probably not doing a lot of large-scale analysis on my November 2018 yet anyway, so why have the index there, right? So I could make all sorts of arguments for not just the optimization of those data sets, but the usage patterns of those data sets and the types of indexes I would put on those data sets. And then fill factor, right? Fill factor, a lot of people are saying you don't need to do maintenance anymore, you don't need to worry about maintenance. I totally disagree, right? There's many aspects to splits and fragmentation. It's not just the random I/O versus sequential, and having solid state means you don't have to worry about the random I/Os anymore. It's the whole process of splitting. It's the split of the pages. It's having two not full pages on disk. It's the logging of the split. It's the then having to have these pages in cache. It's not just the random I/Os, right? So solid state is great, okay? I'm a big fan, right? Solid state everywhere. Oh, I should get a check for that from somebody, right? But seriously, right? It's expensive, and we can't do that everywhere. And again, that's one of the benefits of architecturally thinking about our table and its design and changing that strategy, okay? Statistics. I spent the whole day yesterday talking about statistics. I mean, I'd love to do it again. I love that topic. But when we start to talk about the histogram, right? The histogram has 200 steps, no matter what the size of the table is. Now, if your data is evenly distributed, to be honest, having only 200 steps might be fine. But even if some of your data is evenly distributed, I've never seen an environment where every column of every large data set is evenly distributed. It's kind of an impossibility. And as a result, we need to have statistics that are maintained and updated much more frequently than maybe even weekly, maybe even daily. I've got some environments where, depending on what you're looking for, we might want to update stats every 15 minutes, every half an hour, which you can't possibly do that on an 80 billion row table. But if November, just think about this for a second, if November's data, forget everything else, if November's data were isolated in some way, and we just had November's data, then I might be able to update statistics more frequently. I might be able to rebuild indexes more frequently. I might be able to set a much more appropriate fill factor. I would be able to manage and control November a lot more successfully because I wasn't burdened by the other 9 years of data that my table has. So I think of this really as a data set, but not necessarily just a table, right? I might want to have multiple tables. And replication. Now, I know replication sometimes gets a bad rap, and people are like, oh, replication. There's a lot of power to replication, but there's a lot of pain to it as well, especially if you have some kind of problem and you have to reinitialize a subscriber with an 80 billion row table. Well, if November is isolated, and you've already successfully replicated 2009, 2010, 2011. I mean, if you think about it for a second, once that read-only data has been replicated, you don't need those publications anymore. You don't even need to be looking at those anymore. And now you just have a little tiny, per se, publication, I mean, tiny comparatively speaking, right, for October and November. And if something goes wrong, then that's all you have to reinitialize. So it's amazing when you start to look at all of the different aspects of management across often distributed environments, not having all the data in one table is actually really beneficial. I know SQL Server can support all that data in one table, but I want to optimize that data as much as I possibly can. And for me, that actually means architecturally changing the way I structure it, okay? So that's the first most important key point. These data sets do not have to be in just one table. So now we kind of get to this question, right? Well, at what point, Kimberly, do I have to think about this very large table and possibly splitting it? And of course, is anyone going to figure out, let's see, 37 minutes in, or what is it, 42 minutes? No, I don't even know, 30 minutes in, whatever. It depends. You knew I'd say it at some point, right? But it does, it depends. And unfortunately, very large table is as lame as it sounds. It's totally nondescript, right? And TLA stands for three-letter acronym. I'm sure you've been inundated with these all day and for your whole database life, right? But the biggest problem with VLT is that some environments are going to have problems with tables earlier than other environments. And the smaller systems that have less memory are going to start to see problems with a 100, 200 gig table a lot earlier because they only have 64 or 128 gig of RAM than a system that has 2 terabytes of RAM. Okay, so my argument in general, right, is that I start thinking about partitioning at least when tables start getting to 60 or 70 gig, right? And they have very certain patterns and properties, and I'm going to talk more about that. Consolidation, though, is a great point. I put that on here just as a reminder because a lot of you are dedicating virtual machines and certain environments to, one of your critical systems, but by consolidating, you're also limiting the resources usually that it has to maybe 32, 64, 128, and you think, oh, it's dedicated, but it's also fairly limited, and you might there also notice more problems with certain environments and certain tables. And even, I could go further there and say certain structures can be more problematic. So thinking about the physical aspect of queries and data access patterns and like what has to go into memory, for example, becomes hugely important in consolidation, right? Because if your patterns are, 2009 we're not accessing very much, 2018 we are, right? If your data is clustered by a GUID, where is 2018's data? Everywhere, right? And my point is that 20 terabyte table, even though really we're only active for 2018 conceptually, physically 2018 is everywhere. You essentially need to put that whole data set in cache. So it's interesting. I have a course on Pluralsight that I call Why Physical Design Matters, right? And it's interesting because a lot of environments, You know, developers just think SQL Server's a magic black box, and don't get me wrong, there's a lot of cool stuff, amazing stuff that SQL Server does. I've spent 28 years of my life on it. Obviously, I like the darn thing. You know what I mean? I do. But think of this, even just this room full of people. All of you have exactly the same data and exactly the same workloads. Right? No. I mean, it's a huge variation, and SQL Server has to support all of that. And it can. But you have to know how to do it, to be really honest. I mean, if you only have 100 rows and 50 users, I mean, it might be really critical. It's a lot easier, right? You probably wouldn't be here if that were the case. But as your databases get larger, and again, it depends on the environment as to what that really means, you start having problems. And if you don't address those problems early enough, you're going to get to the situation where you can't rebuild because it takes 47 hours. And so now you stop doing rebuilds, and things maybe work for a while until they don't, right? Until the table is now really big and has a lot more problems. So I'm just saying, how do you decide? You want to decide early, first of all. The key thing that I think of, though, is, and the key area where I get the biggest gains with partitioning is you have this date and time related data, where the older data isn't accessed as much. The newer data is core critical. I mean, don't get me wrong, there's hash-based partitioning, there's list-based partitioning, there's other strategies, but the type that I probably do 95+% of the time is usually date-time related. Does anyone have that kind of pattern where they have date-time related data? Okay, I mean, it was the majority. I mean, some of you are kind of raising your hands very lowly here, but I did see quite a few hands. So your table's increasing and increasing in size. You're keeping more and more data around. It's starting to give you problems in terms of maintenance, and hopefully you're not yet at that point where you can't do the maintenance because the table is too large. And of course, performance, which you might just attribute to the fact that you have more and more data, but it could actually be statistics problems, caching problems, could be maintenance problems. I mean, there's a wide variety of problems that you could start running into that maybe you're just attributing to size, but if you change that architecture, you might be able to resolve quite a few of those problems, okay? Most importantly, these are the three key, most important points for me to basically say, okay, this table should be partitioned, okay? You have access patterns that are wildly varying. Okay? You have different criticalities to the data, right? You've got the 2018 and the 2009, vastly different importance and criticality, right? And you're keeping the data pretty much forever. I mean, if you start deleting the data, then essentially at whatever point you decide to start getting rid of the data, your table will kind of maybe stabilize, although that's not necessarily true if you keep getting more and more sales, right? Because it might be the older data where there wasn't that much that you're starting to get rid of, but you're just getting more and more and more for 2018. I mean, good for you. That's a good business issue, right? I mean, I hope that's your problem, but the point is those tables getting larger and larger is what you need to address earlier. And a lot of people don't really address them until they can't do maintenance or until they have some really big problem. And I've had people come up to me and say, I have a really large table, and of course I don't even know what that means when somebody says that, right? But I remember one person said, I have a really large table, I have like 20 years of data, and I have a partitioned 3 terabyte heap. And I remember kind of going, okay, so an online rebuild to a clustered index of a 3 terabyte heap effectively needs 10 terabytes of space in a fully logged environment. Right? Because you've got the original 3 terabytes, you've got the 3 terabyte that needs to be sorted based on what your clustering key is, and that happens in the database. By default, you've got about 75% or so, or I should say, about a quarter or so in sort space. So that'd be another 0.75 terabytes. So we're looking at almost 7 terabytes in the database. And then if we're talking fully logged, this is a size of data operation in the log, so we need 3 terabytes there. So we're talking about 10 terabytes to fix this table. Now there was a way to do this. It was already partitioned. Phew. So with a little bit of downtime, meaning some of the data wasn't accessible, we could switch out different partitions create a partition table and a partition scheme that was correctly partitioned, build the indexes that we wanted, and then switch the partitions into the partition structure so that we didn't need 10 terabytes. We only needed the small partition amount of data to be built, and then we could get rid of the workspace, and then build and get rid of the workspace, and build. Of course, the log still needed the space, but if we're backing up the log and allowing the log to be cleared, then we don't necessarily need 3 terabytes actively in the log. And that was a little geeky, I mean, but very cool. And, right? And the fact is, we could do that largely online. Meaning we didn't have to take the whole database off, but of course, once something got switched out, that data was effectively not visible to the app until we kind of migrated everything over to the correct structure. But the point is, once you start partitioning, especially even maybe in the interim, go to partition tables, but then in the long run, go to kind of this partition views, partition tables architecture that I'm going to recommend. You can do this in stages, and even moving to a partition table can be done as an online operation. There's some restrictions, okay? It might not work for you, but there are some cases where you can actually do that as an online op. It's big, it's gonna take a long time. I wouldn't do it at 10 o'clock on a Monday morning, but you know, you can. But a lot of this is enterprise, right? And I am expecting, as your tables start to get really large, if you really want to take full advantage of partitioning, you probably are going to need enterprise. You can do a lot in non-enterprise editions, and I actually saved one company. It was quite funny. We did consulting just for like one day, sat in kind of a conference room and talked through, and I ended up basically being able to help them for what they needed to use standard edition. And at the end of the day, they're like, you saved us $30 million, you know, or something ridiculous like that, and I kind of went, I have got to come up with percentage-based consulting, right? Because like I charged them for like 6 hours, you know? And I'm like, damn. So my point though is, as these tables start to get larger, it's very, very likely that a lot of you will have to consider the enterprise edition. But you can get away with a lot with partition views, right? And partition tables, even if you're 2016 SP1 or higher, you can use in non-enterprise editions. But you end up with some limitations to things like column store and the memory space for column store if you're not in enterprise, right? And there is a session on column store tomorrow because I just ran into Bob Ward and Ryan Stonecipher. So definitely check that out if you're going to want to learn more about column store. And I'm going to mention a little bit more on it. Question? I'll see if I can do a couple questions here.
Yeah, quick question. Sounds great for one table. Let's say you have 20 tables, and 20 tables in each of, say, 5 days. Does the same paradigm work?
Yep. So the question is, you know, this sounds good for one table. Is this going to work across multiple tables and multiple databases? I am talking about a scale-up strategy. So what I mean by that is I am going to better use the one server. I'm not talking about like distributed partition views, for example. I'm not talking about sharding here. However, this same strategy can work for any of the large tables, and often multiple of the large tables will probably leverage the same pattern, right? Because a lot of you will have sales headers and sales line items, for example, that will end up having the same pattern in criticality, in, you know, the number of rows and all of your business rules and requirements. So you'll end up partitioning them in exactly the same way. But it might be that you end up partitioning other tables a little differently. And this is actually an important point to make as well. I went into one customer once, and they had somebody convince them that they needed to partition all of their data by day for like 3 years back. And I'm horrified by that because, to be honest, you don't need to, in any form of partitioning, you know, use like the same monotonic pattern. Like it doesn't have to be day, 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 day. Because in a lot of cases, you're not going to do any maintenance at that level. I mean, maybe you will. But usually when I start talking about older data, I might have not that much data, like I said, from 2009 to 2012. So I might end up lumping together 2009 to 2012 in one structure all by itself for one particular table. But for another table, I might go by month. Another table, I might break it down just by year. So I look at multiple factors, but yes, the same concept applies. You just don't have to use that same pattern uniformly unless there's a very distinct, very common access pattern like joins and so forth, like sales and line items, that really does kind of want that same pattern, okay? No, it's a great question. Okay, so let's get into this more. So for me, a VLT, I tend to think starts to be interesting around 60, 70, 80 gig, which for some of you, you might end up going, oh, I've got a lot of tables bigger than that. Maybe I should be thinking about this, right? I know that seems small. I'm not saying you have to fully implement things at 60, 70 gig, but when a table starts getting to those sizes, that to me is indicating that we're probably keeping data, our tables are growing, and if that is going to be the pattern, the sooner you deal with it, the easier it's going to be to deal with, and the better your performance and scalability is going to be earlier on. If you wait, it can be very challenging to fix that problem later, okay? So, now there are other forms of partitioning, and just for completeness, I wanted to give you a little bit on these, and then I've got some links to give you more insight. I'm not going to talk about hash-based partitioning. I mean, you can do that, where let's say you have a table that's forward-only inserts, and you want to try to get rid of like page latch EX weights because of things like identity. You can actually create your own kind of partitioning strategy where you do something like whatever that ID is, if the ID is just 1, 2, 3, 4, and you can create a column that's like ID mod 5, so that you essentially get 0, 1, 2, 3, 4, and you're just round robining the inserts across those buckets. And then you can have those on different LUNs. And that sounds great, and it can really help your insert performance, okay? Absolutely. But what else are you doing to that data becomes the next problem you're going to have to solve, because you're kind of just moving your problem. Because if you're going to do a lot of queries against that data, you're going to need non-clustered indexes, and those indexes may or may not need to be aligned, right? Aligned indexes, to get elimination and good performance, you always have to supply the partitioning key in your queries. If your queries aren't going to be supplying this bucket, then you're going to want unaligned indexes. And unaligned indexes means all the data is going to go into one index, which now means you might have a new hotspot depending on what the data is for that index. So you're kind of just shifting your problem. But if it is just inserts, I mean, there's so many options here. You could also change that staging area into an in-memory table, right? And you have a durability question to answer there, but you might be able to get those inserts in really quickly and then make them durable, right? And do more of the optimizations after that data's come in, but get rid of a lot of your problems on insert by using the in-memory tables as a staging area, right? So there are options, is my point. It depends on what problem you're trying to solve. And if you're only trying to solve that one problem, like inserts, then there are some easy solutions. But as you start to look at the entire environment and all of the queries and everything that's going on, if it's not that isolated and localized in terms of activity, then we have to think bigger picture. I got to think of all the indexes, all the types of requests. And that's where I wouldn't use hash-based partitioning, okay? But I did want to put that on there. And then I get questions all the time. SQL Server supports list-based partitioning? I didn't know that. We only have range-based partitioning. I really want to say that first. But if the only values you have are the values you've listed, you're effectively doing the same thing that Oracle calls list-based partitioning. But you have to be really careful. Like, let's say you deal with, you know, Washington, Oregon, California, you know, and that's kind of sometimes how I think of it going down the coast, right? Well, if I create my function as Washington, California, Oregon, and then I say it should go on the file groups of Washington, California, Oregon file groups, SQL Server alphabetizes the values kind of behind the scene, right? So I said Washington, California, Oregon, or Washington, I don't even know what I said, sorry, Washington, Oregon, California, but then I listed my file groups that way, so what ends up happening is like California goes on the Washington file group. Okay, Oregon's going to be okay, but then everything is in the wrong place because SQL alphabetizes. So if you are going to use list-based partitioning, you want to make sure that you list everything out correctly and you visualize what data is going to go where, and you follow through by checking to make sure that you got things right, okay? But anyway, I just mentioned this one. And I did talk about this in the white paper. I know the white paper seems old. The 2005 white paper that I wrote is all scenario-based, so it's still pretty valid. But there's a 2008 white paper that talks about some new features, and then there's more updated resources I'll be pointing you to, again, for new features and things like that. Okay? So yeah, you have to be careful, because if you don't get this right, you might not put the right data in the right file group. Okay? Now, what do I mean by partitioning? Okay? There are two features primarily associated with partitioning, and those are partition tables and partition views. Now, partition tables are the new shiny object. I mean, I can't even believe I can say new shiny object, because it was 2005 when it was new. But for whatever reason, because they're newer, a lot of people think that partition tables are, you know, the best thing, and that you should always do partitioning with partition tables. And here we are, you know, 2017, 2018, and there are still problems with partition tables. Now, don't get me wrong, partition views are no picnic either, okay? They both have pros and cons. The irony, and this is going to sound really strange, they both have issues, okay? But ironically, when you combine them together, you actually get mostly positives. You get rid of some of the negatives by putting them together. And it sounds strange, but I've got some pictures. I'll give you a lot more insight into this. But we've had partition tables since 2005, right? And they are easier from a management perspective. I was really debating on how well this is going to work, but I'm going to go for it. Okay? Yeah. So I want to give you a little bit of insight into what I mean by administration is easier and management is easier. If I just have one large, hold on. I don't, there we go. Oh, you got to be kidding me. What is wrong with this? I know it worked earlier. You guys saw me. It's like, what'd you say? Go back to my menu, and I got out of tablet mode, is what you're saying? Oh, forget it, I won't draw there. Giving up. But, all right, administration and management is easier. I can't believe that. I actually switched machines from yesterday, because I had a weird pen issue yesterday, and I brought a different machine today that I tested before I got up here, and it worked beautifully. Of course I did, right? I did. Anyway, but administration management is easier. And what I want to give you kind of some insight into this. If you have a table that's partitioned by month, right, and you have 12 months, I was just going to draw like 12 chunks, so it's not like that exciting, right? But anyway, so you have 12 months, and your table is partitioned. So you have this thing called a function and a scheme. For interest's sake, the function is what logically breaks down the data by month, and the scheme is what maps that logical breakdown of that function to the physical file groups, okay, and to where you're physically putting that data. So you've got this table that's partitioned. Then, okay, what gets interesting is you create an index on that partition table. Now, there's some rules around here, and I've got like 3 index pages of rules, but one of the things that's very cool when you create an index on a partition table is that the default behavior is that that index will be aligned with that partitioning scheme. So if there's 12 partitions, SQL Server essentially creates a little B tree for each of those partitions for that new index structure. And you don't have to go and create individual indexes for each one of those separate pieces. If you create separate tables that are under a view, there is the potential for a world of pain, right? Because SQL isn't necessarily going to check your business rules. SQL Server's not going to guarantee that you haven't goofed up with like constraints, right? Like, what if you forget February 29th? I mean, I know that sounds like who could forget February 29th? 2008, you could not check in at an electronic kiosk from United because they forgot February 29th. SQL Server 2008 wouldn't install on February 29th. And it was shipping in March, right at the beginning of the month, and there were all these people freaking out. Now all they had to do was change their date. That was okay, but still, right? There were like all these wonky things because people goof stuff up around dates. And with a partition table, for those of you that have created partition tables, you define boundaries. And they are defining that data either goes here or here. There is no, potential gaps. But when you have separate tables physically, you're going to have to constrain those tables. Now, you could say greater than January 1st and less than January, or equal to January 31st, but if you have time, that's an issue. And then you might try to be clever. Well, less than January 31st at 23:59 and 59.997, right? And some people don't know that one either. But my point is, there are ways to be better. Like, I don't even want to use my knuckles and figure out what days there are in whatever month, right? I know some of you are like, what is she talking about? That's how I remember. But my point is, for the view for January, or I should say the table for January, I'm going to say greater than or equal to January 1st and less than February 1st. Greater than or equal to February 1st and less than March 1st. And now I've got no mystery and no gaps, right? And no problems. Assuming SQL Server has all of its dates correctly, right? But my point is, these features are incredibly powerful, but you have to get things right. And there's a lot of places where you can mess up, like the 997. Hi, Randolph. There's a lot of places where you can mess things up, right? And get things wrong. And sometimes you don't find until later. Like my favorite question on forums, I thought merge was supposed to be really fast. Yeah, okay, you guys are the ones that know what happened. You merged a boundary point that wasn't empty. Oops, right? But you should learn these things earlier, right? And again, I'm gonna give you the architecture, but you'll have to make sure you're comfortable with the syntax and so forth. But the architecture is what people mess up. Really, this is the most important. Okay, so let's talk architecture, okay? If you have date time-based patterns, then you probably also fall into the category of the sliding window scenario, but I don't know if you're gonna move off to a secondary system for reporting. You might just have the one system that is OLTP, right, and reporting. That's what I mean by hybrid. But the sliding window scenario is also kind of the canonical case that people use for moving data to a data warehouse. And you can implement this scenario either way, partition views or partition tables. But each one, like I said, has their own pros and cons. And probably the most important thing here is, for some of you guys, is your data might not be getting removed on the OLTP side of things. I mean, you might be moving it over to a data warehouse because, as we all know, from a read committed and inconsistent analysis perspective, when we do a lot of reporting in OLTP environments, we have the potential for anomalies, right? Unless we're using versioning or we're changing isolation levels. And kind of my point is, we have data warehouses that are up to, let's say, the end of the month, last month, so that all the people doing their analysis are getting the same version of the truth. Right? And all their reports are adding up. Because if they're doing the reporting against the OLTP environment, and we're not using versioning, or we're not changing isolation, then we can have all sorts of inconsistencies potentially occurring in that reporting because of the nature of locking and isolation. Okay, so my point there is, you might have both, right? You might want to do real-time reporting in that OLTP environment. You'll probably want to use versioning there as well. But to make that reporting efficient, you can break that data down into separate tables in the OLTP environment and get a lot better statistics, management, fill factors, and again, therefore performance. And it all goes around this date-time data pattern. So functionally partitioning the data, there's two aspects, like I said, that you get gains: availability and performance. And from an availability perspective, I have a presentation online that I did, I want to say it was like past 2012 or 2013, and it was part of past TV, like this one is, so you guys can access it without the DVDs and so forth, which is kind of the cool. But why you don't have the DVDs, I don't know. You should definitely be getting those. It's very useful, right? But anyway, I'll point you to that session so you can get some demos on kind of how partial database availability and online piecemeal restore works. But this is one of by far, one of my favorite features about SQL Server. I love, I'm almost embarrassed to say I love backup restore. Really? Did I just admit that out loud? It is. It's one of my favorite features, and there's so many things that you could do. The very first article I ever wrote for SQL Forum Journal was in 1992, and it was backup restore for SQL Server. So I love kind of all of these flexible backup restore options where you can do file-based backups and file group-based backups and file group differential backups. And as you guys have larger and larger databases, you don't need to be backing up. I mean, I think about the wasted resources for a lot of folks that are doing full database backups, like every night or every week of data from 2010. Why are we doing that? Because it's easy, I'm with you. But at some point, we're going to start realizing the expense of that. I remember I had this one company where they started implementing internally chargebacks for backups. And the day that got implemented, it was the funniest thing. I was like sitting on my computer and I got this email that was like, hey, Kimberly, I know you talk a lot about file and file group backups. We're really interested in talking to you about that. And I'm like, oh, cool, right? And I didn't think anything of it. An hour later, I got another email. Hey, Kimberly, we're really interested in talking to you about file and file group. And I'm like, is this a joke? Like, is somebody like hidden camera on me? And then like another hour or so later, I got a third email. And I'm like, okay, what is going on here? And they're like, they just implemented chargebacks, and now we have to pay when we do a full database backup, and we don't want to be backing up all that data that's, you know, not changing every day because it was going to charge at the time, this is like 10 years ago, $1.26 a gig per backup. Which isn't terrible, but if you back up a full database every day that's largely static, then it is kind of terrible. And people that aren't paying for this, per se, right? If we just naturally back this stuff up and don't think anything of it, the resources that are wasted are crazy, okay? And I know there are hardware ways to possibly dedupe things and, you know, deal with redundancies. But you have to be careful that you really understand what those systems are doing, because you might end up putting all your eggs in one basket. And if that basket is lost, you're going to be in real trouble. So it might be a lot better to be more strategic with the way you do those backups. And if you have that VLDB, one of the coolest things you can do, right, is actually take data sets, make the file groups that they're on be read-only. And after you mark them to read-only, you can do a backup of those file groups and effectively never have to back them up again. Now, I wouldn't say never, okay? Because I've actually seen companies where they were like, oh, that backup is on that tape format. We don't have those anymore. And then they go to eBay to try to find one. And you just kind of go, are you kidding me? Nobody thought about this, and that backup is on, you know. So I'm not saying never ever do a backup of that data again, but I'm certainly saying you don't need to be doing it every day, every week, every month. And by architecturally splitting out that data, you get a lot more benefits with read-only file groups and managing that data, okay? So significantly better availability too, because like I said, partial database restores, you can even in standard edition, a lot of people don't know you can do this. You can actually bring a database online in the standard edition partially. So you could, even in standard edition with a partition table, restore 2018 and 2017 and then bring the database online. You cannot then do an online restore of 2016, okay? Meaning you have to take it offline to restore 2016, but then you can bring it online again. So you could end up, let's say, restoring some of the older data over the next few evenings so that at least you get 2018 and 2017 online really quickly. So there are things you can do, even in the standard edition, with partitioning, even from a partial database availability perspective. So that's a very cool capability. And of course, you know, you don't want to necessarily spend all that money for RAID 10, triple mirroring, solid state, right? You want to put some of that older data, compressed, RAID 5, right, and so forth. So now the indexing here. I only have 3 slides on indexing, maybe 4, maybe 5. Actually, I think there's 6. But anyway, so indexing. This is one of my favorite topics for sure. It's not easy, okay? Row-based strategies or row store strategies, I mean, that's the beauty of column store. There's no key, there's no include, like there's literally no thought that goes into creating a column store index, except the fact that you should be creating them. They're like the greatest thing ever, okay? They're simple, they're very efficient, but they're best for specific workloads, okay? I'll say that. But it does depend on what version you're on. And what I was trying to do on this slide is not spend an hour on 2012 and 2014, but really just try to convince you of this. You should not be architecting or designing on any system except 2016 or higher. Ideally 17, right? And ideally vNext, right? Because you will get things like not just all of the enhancements to column store, because there were lots of restrictions in 2012 and 2014. So all those restrictions are gone. And in fact, the coolest thing about 2016 is that you can have a clustered column store or a clustered row store index. Okay, so you can choose to create your table structure either way. But then you can also have non-clustered row store indexes, or if you've chosen a clustered row store, you could have a non-clustered column store index and non-clustered row store indexes. And you might think with column store that you don't need indexed views, but you still can really benefit from indexed views as well. Okay, so in 2016, you can do all of those things to all of your tables. Right? So that's where I really want you to be thinking. Now, don't get me wrong, if you can't go there yet because you have some application dependency or something, there's a lot you can do in the other versions, even all the way back to 2008 or 2008 R2, but I'm telling you, I wouldn't put a lot of energy into that. You need to get off of those older systems. And I know a lot of people have been saying that, but you really do need to think about that as soon as possible. So now let's just compare and contrast row store and column store, especially around kind of what you can do and what your benefits are. Row-based or row store indexes do support compression, and you can do that compression at the partition level, which sounds great, okay? Column store indexes actually have even better compression, and as of 2014, they added an even further archiving level of compression for column store. So that's hugely beneficial, again, for the older data. Now, row-based indexes, you might think if you've got column store, why do you even need row-based indexes? Column store is great for large data warehousing types of queries, okay? Large joins across multiple tables, right? Column store, column store, column store, okay? But I largely use column store for more of my read-only data sets. And I also want, generally speaking, to still be able to look up sales by sales order number or customer number. So I want to do point queries. And unfortunately, column store is really optimized for large-scale data warehousing and large reads. And there are some very cool things you can do, but the smallest data set that they essentially can read is something called a segment. And that segment is essentially 1 million rows. So you're not doing very efficient point queries. So you really need non-clustered row store indexes as well as column store. And it turns out that you really couldn't do everything you wanted to do in 2014 or 2012, but in 2016 you can. So I've kind of listed some of the concepts here. You know, a wide variety of features that you can do, whereas we're large-scale aggregates, large-scale joins, large is what you think in terms of column store. But having said that, as I mentioned, you can only create 1 column store index per table. There's no key, there's no include. Most of the time when people create a column store index, they basically put every column in there, unless they have a data type that's not supported, and there are a few data types that aren't. But largely, people have the bulk of their table in a column store index, and often find that even though they've put the whole table effectively into the column store index, that the archiving or even just the regular column store compression brings that table down in some cases to like 1/10 of the size. I actually just chatted with a gentleman before I came in here, and they had, I mean, it's almost unbelievable. They had like 300, 1/300th of the size of the database. So for every 300 gig, the column store data set was a gig. which is crazy. I mean, you have to have the right data for that really to happen, right? If all your data is GUIDs, good luck with that, okay? If your data, right? And that's an interesting point to even make. Some data is more compressible than other data. So even sometimes the design of your environment can be very negatively impacted by data type choice, index choice, and it's just an interesting point. They had a very financial focused data set, lots of numbers, not GUIDs, right? And so they got just incredible compression in the column store index, which is, it's just amazing, right? And when you're bringing data sets down to like 1/300th of their size, you could almost even argue that some scans aren't even an issue anymore, right? So you really, if you're not trying and using column store, you should be. But here's the bad news, right? If you have just one table, you can't create column store on just a portion of that table. And you might not want column store on the OLTP side of things. But if it had been separate tables, you have a tremendous amount of flexibility. And that's what I'm about to show you. So, okay, partitioning level features and frustrations. Okay, I really wanted to make sure that I hit some of the problems that I've hit over the years and made you aware of them so that you'll know earlier of some of these things. But one of the coolest things about row store indexes and partition views versus partition tables is that you can do kind of anything you want on the base tables under this partition view, and you don't have a lot of the kind of fast switching rules and restrictions that you have on partition tables. Meaning this, in order for a partition table to fully support what we call switch out or switch in, which allows you the sliding window scenario on that partition table, all of the indexes have to be aligned, right? So you can't put just some index on one data set, even though you can, right, like with a filtered index, but then you'll mess up fast switching. So you'll have to drop that index, do your fast switching in or out, then put your index back on. And if you had a whole bunch of specialized indexes, because let's say for whatever reason we're trying to analyze 2012 data a certain way, or we got, you know, audited or whatever for 2014 and we need to do a whole bunch of IRS queries and stuff, so we want to put a whole bunch of indexes on 2014, if that's all in one data set, we can do that, but then we limit our features for fast switching. If these are separate tables, I can do anything I want on any of those tables, but I will throw this out there. It is harder to manage them, because if you do want to optimize for a particular type of query and you have 15 tables, you'll have to create that index on all 15 of those tables. Now, is that hard? I had one customer that told me that they wanted essentially as much as I could possibly do automated. And I wrote code that would basically allow them to pass in some parameters of an index, and then I would dynamically figure out the tables that underpin that view, and I would put all the indexes on all the tables in just one, basically, procedure, right? So you can do this, and you can also even just copy and paste and have a template, I mean, to be honest. I mean, it's not like something you're gonna be doing. I mean, if you're changing indexes every day on 25 tables underpinning a view, you have other problems, right? So, I mean, you don't have to automate it per se, but you can. But you can also just kind of have a template, fix the template, and then as you want to add an index or drop an index, change the template. So it's not hard. It's just you have to be tedious. You have to be focused. You have to know your structures, and you have to manage them correctly. So that is kind of an issue. Column store index compression, like I said, in 2014, they added the archive compression, which gives you, for the older data, even further compression. So that might be really beneficial because, again, you're not using that data as often. One of the big things that I think is an issue is fill factor. I mean, we can do compression with row store indexes for different partitions and have different levels of compression. But you cannot set for a partition table different fill factors and pad index across the partitions of your partition table. Whereas if these are separate tables, you can do whatever you want, right? So that's a huge benefit in my opinion. Okay, so now what are you going to partition over? Okay, you better make this decision correctly. I had one environment where they're like, we really want to analyze certain hours during the day. Like, we want to analyze what happens from 2 p.m. to 3 p.m. And I'm like, okay, that's interesting. And they ended up partitioning by hour, but not putting the date in there. So, yeah. And so what ended up happening is like they had from 2 to 3 p.m. of every day in the same partition. And then so you really want to make sure you choose your partitioning column wisely. And you have to make sure that everybody kind of agrees on this, because whatever you are going to partition over, you have to make sure that everybody is using that in their queries to get proper elimination. But one of my favorite things about partition views, imagine that some of you have multiple columns that are somewhat correlated, meaning you're going to partition by date, right? But you also have something like an ever-increasing order number. If you put 2 constraints on each of those tables, one that says it's January 1st less than February 1st, but as the data grows, you also constrain it by ID. As weird as that sounds, you put another constraint after you know what the values are, and the last data set can just be greater than, until you know, right? But then you constrain it like 1 to, it might not be as simple as 1 million or a 2 million. But if you put the constraints on the IDs, you can actually partition over multiple columns using partition views. And SQL will properly do elimination for queries for both. Now, you still have to have one that's effectively your updatable strategy. So if you're going to do what we call updatable partition views, you're going to have to make sure that whatever is that partitioning column that you want to use for inserts, updates, and deletes, for partition views, it has to be the leading column of the primary key, okay? So that might be a bummer for some of you, because that might automatically mean you're going to have to do some re-architecting. You might not be able to do this inline into a production environment. You might have to do this in vNext with more significant changes, okay? But certainly in a new environment that you know is going to grow wildly out of control per se, you can start with the table being non-partitioned, but know how you're going to deal with it over time by creating, for example, the primary key to lead you later to be partitioned correctly, right? So I've actually worked with some customers where we talked about how to create the tables that aren't yet partitioned, but so that we could partition them later easily. So I think about some of these, and some of these seem a little bit strange. Like, if I want to have my partitioning column to be date in my sales table, date is usually not unique, and I usually want my partitioning key and my primary key also to be my clustering key. It technically doesn't have to be, but that can work out really, really well, that combination. But if now I have date, date's not unique, and usually you want clustered indexes to be unique, so you end up putting something like order date and order ID. So that's now your, or let's say, sales date and sales ID in the sales table. But now what about line items? Because most people would end up having line items just point to like the order number, not the date. But now that you've made the primary key of sales to be the sales date and the sales order number, your primary key of the line items table is going to have to be the sales date, which most people wouldn't ever think about pushing down, right? The sales date, the sales ID, and the line number. Okay, so there are things that you might have to change about your structures to really make them partitioned the same across those related tables. And that's why you might use the same strategy, but it might then require that the tables be different than what they look today. Okay? Now, partition tables, you can only partition over one column, but it can be, as I mentioned, a persisted computed column, which can be very beneficial. Okay? Now, for the best performance, and it was really funny, I just had this recently where somebody said to me, oh, well, when they're doing the joins, they don't specify the partitioning column. And I was like, well, then it's not going to work. Like, I mean, let's be very clear, everyone. If you want good performance, everybody has to agree, right? And you have to make sure that everybody is using that same partitioning column. Okay? Now, I've got 2 slides on primary keys. I mentioned these, but I just put these in to make sure it was really clear, because if you mess this up, you won't be able to do this easily. For updatable partition views, they require the partitioning key to be the leading column of the primary key, okay? And there's no other requirements. For a partition table, it's way more challenging, okay? You do have to have that partitioning column in every unique index, but it doesn't have to be the leading column. But it does get even a little bit more challenging than that. And I've got notes here, but I'll just kind of leave it at that and say the only thing you have to do is put the partitioning column in unique indexes. Okay, and there's a little bit more from an optimization perspective that's on there. Now here's my picture, and this is kind of my summary, all right? If you want to partition your environment correctly, functionally partition your data will look like this, okay? And you know, I wasn't sure if I would draw or not, so I'm glad I did put this in. But you might have a table that is like 2000 to 2016, and that was mostly just because I ran out of room, right? And then I might have another table for 2017 that is partitioned by quarter. And then 2018, for the data that is currently static, I might have a partition table. And as my data becomes static, I switch in to that partition table. So by the end of 2018, or let's say February or March of 2019, once 2018 has really stabilized, right, I've switched in all of the data into that one table. So 2018 is now just one structure. But while 2018 is underway, like 2018 October and 2018 November are standalone tables. They're smaller, they're more manageable, they have better statistics, they can be rebuilt online. I mean, some of you guys might remember that you couldn't do an online rebuild of a partition, even with partition tables, until 2014. I've been able to do it since 2005 because I didn't put all of my data into one table. I separated it, but I made it look like one table to the users by unioning all of that data. But it does require that you constrain those tables, but you end up getting the best of all worlds with this architecture. Yeah, I mean, if there's any slide to take a picture of, it's this one, because this is beautiful, right? I know, I'm so geeky. Do you want to laugh? The first time I ever met Paul, I whiteboarded this. So my joke, no, I'm not even going to go there. But anyway, this is just a very cool architecture that solves virtually every problem that we've had with partition tables since 2005. Lock escalation, right? They added partition level lock escalation in 2008. I didn't need it because I would never escalate beyond those data sets, so I wouldn't have like OLTP blocked by decision support or vice versa. I can put column store indexes on the older data sets. I can use fill factors of 100% on the older data sets. I can rebuild the statistics, well, update the statistics, rebuild the indexes, do any maintenance I want on November, because relatively speaking, it's small. I can put it on faster drives, right? I can make sure it's very redundant, and I can put the 2010, 2016 on, you know, I'm not gonna say RAID 0, but let's say RAID 5 SATA drives. I'm not gonna throw a lot of money at that older data. And with this architecture, you get so many benefits. So that's really everything. I know they look complicated. I have a few summary slides that bring everything together for you. And ultimately, it does lead to that they are complicated, okay? You have to architect them correctly. So I started out, I had the slide, partition views look complicated. And then after I wrote the slide, I went, yeah, really, I need to make that partition views are complicated. Whoops, sorry. So you can end up looking at some of these rules and restrictions, and there's definitely a lot more work that goes into them, but you get so many benefits. And then I have a summary slide here for partition tables as well, with a lot of the weird, you know, things that got fixed version to version, like what they fixed in 2012 and what they fixed, like 2005 couldn't do fast switching with index views. But did you know you can't do fast switching at all, even in 2017 with IFTS, integrated full text? Yet if you have separate tables, you could have full text indexes on the older data, because you'd never have to mess with them because you're not switching in or switching out of those tables, right? So you have to prototype. And I've got links, massive links to all the capacity specifications, but my last summary really is you have to prototype. You have to prototype. I learned about fast switching and IFTS. I know I'm wrapping up right now. I learned about IFTS limitations because I had a customer that wanted that, and I couldn't use it, and I couldn't do fast switching, right? So you need to check your features and what you're gonna try in the architecture you wanna implement before you think it's just gonna work. You might find something I don't know, right? For sure. So you wanna try this stuff out, but it can be done, and it can be done efficiently, and you can get rid of a lot of the problems, almost every problem you have today with those VLTs, by architecturally changing the structure of those data sets. Okay, so when you get this slide deck, there are 4 resource slides. There's 3 partitioning resource slides that are to videos, because I know a lot of people like the videos, like to listen to things and focus on that. And then there's white papers, there's indexing and column store videos, there's high performance data loading, resources, blogs, and white papers, and a couple of other courses that I've done that are kind of tied into this, and Pluralsight and all this good stuff. And I even have a 3-day course that I do on partitioning where I do spend a lot more time on the syntax and how to do all of this. So it's a hard topic, but it can be done if you know some of the pitfalls and you know how to do it correctly. So thank you very much.